In this video we're going to spend time talking about something called the continental drift hypothesis, and it was kind of formulated by Alfred Wegener, and we're going to really focus on four main types of evidence in rocks, fossils, climate, and how coastlines fit together. So keep those in the back of your mind as we go through, and here we go. So, continental drift and plate tectonics really goes back a long time to when people started first making maps of what the ocean floor looked like. Now, for the longest time, people thought the ocean floor was completely flat. However, people being curious, like we are, wanted to determine if that was true or not. So we started taking a look and mapping the ocean floor, and we found that the ocean floor is not flat whatsoever. There are flat parts, however, there are large mountain chains on the bottom of the ocean. There are very deep canyons in the bottom of the ocean. And so that kind of led to other questions, like why are the continents where they are? Have they always been there? So we're going to focus on continental drift, the idea that the continents are moving from place to place. Now, what's going to happen is this guy Alfred Wegener is going to propose the idea of the continental drift hypothesis, and like I said, what he came up with is that at one point in history, all of the continents that we have here on Earth were once all together. They were one large supercontinent called Pangaea. And since Pangaea was last formed, the continents have been very slowly drifting apart or breaking apart and then moving to where they are right now. And Alfred Wegener came up with this idea, this hypothesis, based on several different pieces of evidence to support his idea. And we're going to kind of rattle through each of the four different pieces of evidence. Now, the very first one, which to me kind of makes the most amount of sense, is how the continents fit together. And they kind of fit together like puzzle pieces. If you had a map and you cut out all of the different continents and you just kind of sat there and played around with them for a while, you should be able to kind of see where some of these pieces fit together. Now, the best example of this is the coast of South America. So this guy right here, coast of South America, and then the west coast of Africa. Should be pretty easy to see that both of these guys fit very well together, and you can slide them next to each other, kind of like in this picture over here, right? But that's not the only continents that fit very well together. If you would take a map, you could, like I said, spend time and fit them all together into one big supercontinent, which he named Pangaea, which means all land. Okay. Now, the second piece of evidence, which is also very important, comes from one of my favorite things in the world, fossils. So, right now, we know that each continent has its own very specific kind of species based on, where they are, the location, the climate, that kind of thing, right? An example I can give you are elephants, right? Okay, there are African elephants, and then there are Asian elephants, completely different continents, okay, connected, right, but very far away from each other. Now, if you've ever seen African elephants or Asian elephants in pictures or on TV or something like that, they look very, very different, right? But yet there are some similarities, okay? Now, Alfred Wegener kind of used that information along with some fossils to help him kind of figure things out. Okay. Now, these are kind of the most important fossils that he used to help him figure out this whole idea of continental drift. Okay, now I'm going to focus on these guys down here. And what he found is that these particular animals, the exact same skeletons were found in places like Africa. He found fossils of both of those in Africa. He also found the exact same fossils of the exact same organisms in Australia, South America, and what's also kind of crazy is Antarctica. Okay, now these guys were kind of the maybe ancient ancestors to dinosaurs, so this is before dinosaurs. Okay, now Antarctica right now is at the South Pole. There's penguins there. It's very cold. Okay, now these guys would not exist or couldn't survive in an area like that if it was the way that it is today. Okay, so he started thinking, well, this doesn't make any sense. How in the world can I find things that are like dinosaurs that are cold-blooded in a place that's super duper cold? They would die, right? So he kept digging and digging and found some other fossils like this guy, right? Now this guy swam in the water. Now it kind of makes sense that you could find an animal that lives in water at all of these different continents, right? Where these guys down here doesn't make that much sense. How in the world could reptiles swim completely across the Atlantic Ocean? Well, it just doesn't happen. This guy, however, can swim. The problem with this guy, though, is that he is a fresh water reptile, which means he would die in salt water, and the oceans are salt water. Okay, so again, this guy's having a hard time getting to all these different places if he has to cross the oceans. Okay, so that doesn't work either if the continents don't move, or they weren't put back together at one point. Finally, we get to this plant. He found the plant fossil, leaves like this right here, in the exact same places: Africa, Australia, South America, Antarctica. Again, climate doesn't match up, and plants can't move. All these other organisms can move, sure, okay, but plants can't move. How in the world can you find the exact same fossils of the exact same organisms on completely separate continents that are, thousands of miles away from each other because there's an ocean in between them? Okay, well, he figured at some point they had to be put back together. Okay, so really quick, this is important. This is kind of what I just told you. Fossils of the exact same plants and animals were found on completely different continents. Okay, and these continents are separated by the ocean. What does this mean? Well, it says plants and animals could not have traveled over the ocean. So, at one point, they had to be all back together. Okay, and in this picture, you can kind of see the, the overlap of where you found these fossils, right? So we have South America, Africa, India, Antarctica, or Australia. Okay, the only way for Wegener to find all of these fossils in these places, the exact same fossils, is if they were put back together, and then slowly, over a long period of time, they've drifted apart. Okay, so putting this on a map, right, you can kind of see, we already talked about how the coasts match up. Now we can kind of see how fossils are matching up between all of these different places, right? So let's keep going a little bit. Now, evidence number 3 comes from geologic features like mountain ranges. And what's kind of interesting is we have the Appalachian Mountains here in North America. And if we take a look at the rock chemistry, like what they're made of and the age of the Appalachian Mountains, and we compare them to a mountain range in Europe, right here, they are the exact same rock type, the exact same age, and they're both mountains. So, hopefully it's kind of obvious, and it was obvious to Alfred Wegener, that at one point these mountains right here were connected to those mountains over there. Okay, that's the only way. I mean, the Earth doesn't just make mountains that are the exact same in completely separate areas. They have to form at the same place. Okay, and then over time, these big, huge continents drifted away from each other. Alright, so here we go. We're still matching stuff up. Now, not only can we match up South America, Africa, and Antarctica, but now we can start to piece together this right here, right? North America into Europe as well. Now the final piece of evidence is this climate deal, and I kind of hinted at this when I was talking about having dinosaur-like organisms in Antarctica, right? What Wegener noticed is that the fossils, okay, both plants and animals, don't match the climates that we have at the current location right now, okay? So like I said, there were kind of reptiles down here. That doesn't make any sense. And a couple of other things. He found coal deposits, coal, in New York City, NYC, right? Now, we've talked about this before. Coal forms where? Well, hopefully you remember, coal forms in swamps, right? And that's what New York City is known for right now, right? Swamp capital of the world. Not a chance, okay? So, what that means is the continents had to be at different latitudes in order for these organisms and these things to be where we found them. Okay, so that means that the continents at these high latitudes where it's kind of cold had to be shifted down a little bit, and then Antarctica, where it's also very cold, in order to have reptiles, they had to move up a little bit, right? Okay, so they were all kind of huddled together near the equator, all these big huge continents smushed together in Pangaea near the equator, and then as time has gone on, they've moved to where they are right now. Okay, and this is kind of what I was talking about. Alright, so this is what we have right now, and this is kind of towards the time of Pangaea. So, just for review, Wegener's theory of continental drift also kind of starts talking a little bit about the idea of a supercontinent called Pangaea. Okay, and that supercontinent existed about 200 million years ago. It's not the first time or the only time that we've had a supercontinent. Because the continents are continuously moving, we've had dozens of Pangaeas throughout Earth's history. So, not only, if you think about it, not only do we have a big supercontinent, but if you would spin this globe around and take a look at the other side, you also have a super ocean. Okay, now this is just a map of what this Pangaea would look like based on all the names of the continents that we have right now. Well, now you might be thinking, well, Wegener's idea makes sense. He has all these pieces of evidence, and the evidence makes sense. However, a lot of the scientists at the time that Wegener came up with this idea and published his thoughts and gave them to everybody, kind of laughed in his face. And the reason why people did not accept his idea right away is because Wegener couldn't explain the how part of all of this. How in the world can you have this big, huge, thick piece of continental crust move if it's right next to ocean crust? Okay. Now, at the time, they knew that continental crust, the rocks that make up continental crust, is less dense than the ocean crust. Okay. So, how can you have something that's not overly or not as strong as ocean crust smash through the ocean? There's just no way for that to happen. So his theory was rejected, and unfortunately Wegener never really lived long enough to see that eventually his idea was somewhat true and generally accepted among scientists.